So here's a question for you. Do you think that there's a predictable relationship between the production function and average variable cost, average total cost, and marginal cost? Well, if you're smart, like I know you are, you're probably thinking, yeah, there probably is a relationship, right? Otherwise, why would you ask me that question? So, yeah, the answer is yes, there is a relationship there. So, over the range of output along which marginal product rises, marginal costs fall. So, this is how they're related, right? When marginal product is going up, you're getting efficiency gains from things like teamwork, productivity gains like that. What that means, what that translates into is a decreasing marginal cost. So making one more unit actually gets cheaper and cheaper and cheaper when you have the benefits of teamwork. So marginal product going up, marginal cost goes down. But then, right, there's some point we reach the law of diminishing marginal product. So marginal product begins to fall. And at that point, marginal cost begins to rise. So you can see that marginal product and marginal cost are inversely related to one another, right? As one goes up, the other goes down, and vice versa. All right, so let's look at a quick international example involving the short run, average, and marginal costs. So port facilities around the world for shipping across the oceans have observed considerable increases in the average variable costs and marginal costs due to increases in the sizes and numbers of container ships and as increases in their freight, in the freight that they carry. So increase in costs as a result of these things. Now, as these port facilities, they were designed many years ago, and at that time they were designed to handle much smaller vessels, and so their ports have become congested, which has led to spikes in the port's per unit costs, or their average total costs. In other words, per unit costs is average total costs. So this is exactly what we're talking about, right? A limited amount of capital, which is basically the infrastructure of the port, and it's being crowded with a variable input, which is the ships and the containers, right? It's being crowded, and so they're facing increasing average costs, which is basically the upward sloping end of those U-shaped curves that we saw. So they're running into those upward sloping portions of the U-shaped curves. Okay, now what about the relationship between the average variable and total cost curve and the marginal cost curve? Recall that I told you it's important to note that the marginal cost curve crosses at the bottom of the average variable and average total cost curves, right? So the reason for that is because when marginal cost is below average, below these averages, those averages fall. And when marginal cost is above those average curves, the averages rise. So that's why it crosses at the minimum. Now, to help you try to understand this a little bit better, just think about your own grades, right? Your grade in the class is an average, and how you do on the next quiz or exam is your marginal grade, right? Your additional grade. So what would happen to your average if your next grade was lower than your average? Well, it would bring your average down. But what if your next grade was higher than your average? It would bring your average up. Okay, so the logical conclusion of that is that the marginal cost curve has to cross at the bottom because of that. Okay. So that was average variable cost. The same thing's true with average total cost, okay? So in both cases, this is true. All right, so let's look at this here. We've got another table here. We've got this time we've got input. So here's our variable input. So this is going to be labor is our variable input. And as we increase the number of workers, that increases output. Okay, so we don't have any negative marginal product in this case, only positive marginal product. And we can calculate something called average physical product, right? So this is how much how much each unit of labor produces on average. So we've seen this already, right? We're just taking total product and dividing it by our input. Okay, so recall that. And then we've got marginal physical product. You can basically ignore the physical word. Just ignore that. Don't let it confuse you. You can scratch it out if you wanted to. Just think average product and marginal product, okay? But marginal product is how much does each additional worker contribute to total output. So how do they change total output, right? So if we go from 1 worker to 2 workers, the second worker increases total output by 60. So we're just taking the difference there. So that's the marginal product of the second worker. Okay. Now, how does that translate into average variable cost? Okay, right? Well, our variable cost is simply $1,000 per worker. Okay, so average variable cost, we can calculate that as the variable cost, which is $1,000. So each of these workers costs $1,000 basically. And if we divide that by the average product, that gives us average variable cost. Okay, and then marginal cost is almost the same thing. By hiring an additional worker, the additional cost is $1,000, but rather than dividing it by average product, we want to divide it by marginal product, and that gives us marginal cost. So there's that relationship. That's how marginal cost and marginal product are related. That's how average variable cost and average product are related. And that's where the inverse relationship comes from. All right, so here we see total product, right? As we increase the number of workers, the output of the firm increases. And you'll notice that at first it increases in an increasing rate. So the first worker adds 50, the second worker adds 60, the third worker adds 70. So there's like efficiency gains here. But then those efficiency gains start to disappear and this total product starts to get, it's still going up, but it's starting to get flatter. All right, and then we've got average product and marginal product. So marginal product, of course, we've seen this, an example of this before. At first it's going up because the teamwork and the efficiency gains are providing cost benefits. And then average product, recall the relationship between marginal and average. When marginal is above, the average goes up. And then when marginal is below average, it brings the average down. And so in this case, marginal product is going to cross at the maximum of average product in this case. But it basically looks exactly inverse to our cost situation, right? So here's our marginal cost and average variable cost curves. And you see a very similar thing. It's kind of like they just got flipped over, right? So that's why that's because they're inverse to one another. All right, so basically what we're seeing here is that the firm's short-run cost curves are reflecting the law of diminishing marginal product, okay? Right? Reflecting. A mirror image. They're flopped over. So given any constant price of the variable input, so in our example we saw it was $1,000 per worker, marginal cost declines as long as marginal product is going up. So again, that inverse relationship. But at that point of diminishing marginal product, marginal costs, marginal product begins to go down, and so marginal costs begin to go up, right? And so let's wrap up this section here. Well, not quite. Let's stop and think about a sort of a thought experiment. What if the adoption of a technological improvement caused the firm's average product curve and marginal product curves to shift up, right? So an improvement in productivity, in other words. Well, a rise in marginal product at every amount of labor decreases marginal cost at every output level, right? So again, they are inversely related, right? So as marginal product improves, marginal cost is going to improve as well, right? But lower costs are an improvement. Increases in marginal product is increased productivity. Now the shift, both of the average variable cost curve and the marginal cost curve are downward, so both of those curves are going down. So if the wage rate is constant, like we saw in our example where it's $1,000 per worker, then the labor cost associated with each additional unit of output will decline as long as the marginal product of labor increases. Again, you can pretty much ignore physical, don't let that confuse you, but physical product and just marginal product are basically the same thing. That's, again, the inverse relationship. Now, of course, the average total cost curve and the average variable cost curve will also be affected, and they will have their familiar U-shaped, their U-shape in the short run. All right, so this concludes the video on short-run costs for the firm. In the next video and final video, we're going to look at costs for the firm in the long run when everything is variable. Nothing is fixed in the long run.